This slide outlines the summaries of the topics that we have discussed in these chapters on the first-order differential equations. There are various methods for you to solve the differential equations, which include by using the direct integrations, by separating the variables, by substituting y equals to vx, and by integrating factors. First, we discuss about the direct integrations. It is basically a reverse process from the differentiations. The steps of the direct integrations has already been discussed in the previous chapter, chapter 3, on the integrations too. With a given functions, there are various ways to integrate the functions directly. Next, we discuss about using the separating of the variables to solve the differential equations. This happens when within the functions there are existence of the functions x and y, which constitute of two variables only. And these variables are normally separable. With that, you can separate the variables to the both sides, where one side consists of the y while the other side consists of the x. Next, you will integrate the entire expression in order to find the solutions. After that, you may also use the substituting y equals to vx. Next, you have been introduced with the solutions of differential equations by using y equals to vx. These are the steps for you to solve the problem. With a given differential functions, you need to rearrange the functions so that dy dx is on one side and the rest is on the other side. You will need to assume y equals to vx, which after differentiations, by using the product rule, you will get this. You will need to substitute this and y here into the functions which you have already rearranged. This will transform the functions of y into a v and x. Next, you need to rearrange the functions so that the variables can be separated. What you observe here, this step is actually the steps for the separating variables. You have variables separate from the both sides, integrate the entire variable, and the integration outcome from one side will give you v, while the other side will give you x. And there will be a constant c there. With the function in the v, you need to substitute back the v equals to y per x into the function. This v is actually being derived from the functions y equals to vx, which you rearrange it, you get this. Once you have substituted the v into the functions, what is left over, it will be in the form of x, y, and also there is a c. If the question gives you the boundary conditions of x is equals to how much when y is equals to how much, you will need to substitute the boundary conditions into the functions of x and y in order for you to determine the c. Once the c is determined, put into the functions which you have derived. With that, the differential functions is solved. And the last topic that we have discussed in this chapter is the integrating factor. With a given functions, rearrange it into the format here, where you can identify p and q. From the p here, you will need to integrate the p, and the outcome of the integrations is to be substituted into the integrating factors of e power of integrations of p dx. solve this, and this outcome will be substituted into the formulas for the integrating factors. In the formula, there is a Q here. This Q is obtained from the Q which you have identified early on. Integrate this by using the direct integrations method, and the integration outcome will give you in the format of x, y, and also z. Normally, this kind of questions will give you boundary conditions. If the boundary conditions is given, where x and y are given a number, you will need to substitute the value x and y into the outcome of the integration here for you to determine the c. Once you have identified the c, substitute back into the equations that you have derived from the integrating factors. With that, this problem is resolved. What you see from this chapter here, there are various methods to be used to solve the integrations, and this method may be used interchangeable. That means, depends on the situations, you might need to use the separating the variables, and sometimes you need to do direct integrations. For the integrations here, you will need prior knowledge from chapter 3 on the integrations so that you are able to solve these problems. These make these chapters to be rather complex, and you require strong fundamentals of integrations for you to be able to solve the problem in this chapter.